Suppose you put,
Recording in progress.
suppose you push the piston on. Suppose you push the piston down. The
Down.
gas pressure will rise because the particles are now in a smaller space. So
Mm-hmm.
they will strike the walls more often, as you can see. Increasing the gas pressure in this way means that the volume
Of the
of
gas will
gas
decrease. Okay,
decreases.
you see what is happening? Basically, I told you that this is according to the Boyle's law. Okay, this is according to the Boyle's law. What we say is that when you increase the pressure, what happens is that the volume decreases. And why volume decreases? They have mentioned that when you increase the
Because
pressure, the particle will come closer to each other, right? The particle will
yes,
strike with
it
each
has
other,
less
and there
space
will
to
be, yeah,
bounce.
there will be less space available. Okay, so they will have less space available, and ultimately there will be
Yes.
the more pressure will increase inside, and the volume will decrease. Clear? And what will happen if you
Yes.
move the piston away? If you move the piston away, what will happen? Obviously, the pressure inside will.
The
What will happen with pressure?
increase.
No, you are moving
No,
piston
decrease, decrease,
away. Yeah,
decrease.
the pressure will decrease, and
Yes, it's decrease. Yeah,
the
will
volume will increase.
increase.
Okay. So now what they've mentioned, but if you now release the piston, it will move up again. Okay, it will move up again. So the pressure of the gas falls again. Basically, what they are saying, when the piston was coming closer, okay, when you were pushing it down, what was happening? The pressure was increasing inside. Okay, the pressure was increasing inside. So when the pressure was increasing inside, what was happening? The volume was decreasing. Okay, the volume was
Yes,
decreasing. So
decrease.
after some time, when the piston will move up again, what will happen? Definitely the pressure inside will decrease. Clear? Are you clear with this
Yes,
concept?
yes, yes, yes.
Okay. Then the same is true for all the gases at constant temperature. They are saying the same is true for all the gases at constant temperature. What is the condition? Temperature should be constant. If you are going to check the,
Constant.
yeah, if you are going to check the effect of pressure on the volume, you need to keep temperature constant, right? And this is
Yes.
according to the Boyle's law.
Yes.
And what is the relation? That pressure and volume are inversely proportional, right? And if you are going to check the
Yes.
according to Charles' law, if you want to check the effect of temperature on volume, so you know the temperature and volume are directly proportional, right? And you will keep pressure constant now. Clear? Don't mix these two things. These are two separate concepts. Used separately.
Mm-hmm. Okay.
Okay. You have any question? Any confusion? You can.
No, no.
Okay. Now they've mentioned
Okay.
an increase in the pressure means a decrease in volume for a gas. Clear? Or vice versa. A decrease in pressure means an increase in volume. Okay. Have you ever noticed? Have you ever seen a pressure cooker in which
Yes.
the moms cook food sometime? The pressure cooker or any,
Yes.
yeah. What happens in that? Basically, you are heating that, right? You are heating it. What will happen? The pressure inside will increase. So how that pressure cooker will help to for the food to cook? Can you explain this? Think about it. Hmm? Are you there? Rohan, can you hear me? It
Recording in
instantly cooked the
progress.
food.
The what's it called? The volume, the pressure will
Hmm.
decrease. Uh,
The pressure inside. You
No, the
increase,
pressure.
yeah, when you are heating it, basically you
Okay.
are increasing the internal pressure. You are increasing the internal
Yes.
pressure.
Yes.
So that internal pressure, what will it
Yeah.
do?
And the volume goes down.
No, I am just asking about how it will help to cook the food when the pressure will increase. Mm. When you basically, when you are heating something, when you're cooking food on the pressure cooker, what happens is that when there is a flame on, there is increased internal pressure in the pressure cooker, right? And due to that increased pressure, there will be steam inside the pressure cooker. And that steam will provide thermal energy to the meat, and that meat will be cooked. Are you clear? Rohan, are you there? I think when
Recording
you
in progress.
increase the, uh, you have a pressure cooker and you have meat in the pressure cooker, right? And you have placed it on the stove and you are providing it heat. What will happen? That heat will help to increase the internal pressure of the pressure cooker. Okay, the internal pressure will increase inside the cooker, and that meat will be that when the internal pressure will increase, there will be a formation of steam inside the cooker, and that steam will provide heat energy to the meat, and then that meat will be cooked. Clear? Are you getting this?
Yes.
Okay.
Minutes,
Now,
please.
yes. Now moving on to the
Okay. Just give me
sorry.
1 minute. Give me 1 minute.
Okay.
Yes.
Okay.
Recording in progress.
So now we are done with this part, that what is the effect of the pressure on the gas volume and what is the effect of the temperature on the gas volume, and what is the gas pressure? We discussed it in the last class. What is this?
Uh, gas pressures is like where you fill up a balloon and all of the air particles collide with each other, like collide on the sides of the balloon, and it like exerts like it's like when it has a
Hmm.
lot of pressure, it exerts it, and the pressure like the balloon
Hmm.
makes it inflated.
Yes.
The pressure
So basically, we say
inflated.
that when there is collision in the particles, in the gas particles, so they exert pressure basically on the
Yes.
walls of the container, on the walls of the balloon, or on the walls of the container. So it depends
Yes.
on their collisions. The more the collisions, the more
Yes.
the pressure will be. Clear?
Yes.
Okay, now we will discuss about the diffusion. You know about the diffusion? What is diffusion? Any idea?
Uh, I think I know about the
Mm-hmm.
diffusion. I'm pretty sure.
You can give me example of the
Is it
perfume.
like
The perfume, if you.
no? Is it
Mm-hmm.
like where a lot of movements of particles goes from a high
Hmm.
cons from a
Yes, from a
high
yes,
concentration to low
low
concentration.
concentrated area. Yeah, exactly, exactly. Just like the air fresheners, when you spray them, what happens? The
Yes.
spraying perfume or using a room diffuser, it works. How it works? Because the fragrant particles, they move away from the denser area where you have sprayed it to the whole room, to the entire room. Okay, so that those
Yes.
air fresheners, they work on the diffusion. Any other example in your home? Anything?
Uh, mm,
Just like I can give you a
like
hint.
uh,
You get the
hairspray,
aroma.
hairspray.
You get the aroma of the cooked food, right? when your mom is cooking food.
Like hairspray as well.
Yeah, hairspray.
Hairspray.
If the hairspray has smell, then you can definitely
Yes.
get an idea that there is diffusion. And you know the aroma of the baking of anything you're in the kitchen that is being cooked, there will be aroma, there will be smell of that, or
Yes.
there, right? So these all things are
Yes.
example of the diffusion. You know there is diffusion in our
Mm.
body as well.
Mm, yes, because
Mm-hmm.
like atoms, ions,
Hmm.
like that, yeah.
You
In
know
our
when
body, it goes from high
like
concentration
when we
to a low
breathe,
concentration.
when we breathe,
Yeah.
basically we inhale oxygen, right? That oxygen
Yes.
diffuses, basically it diffuses into our lungs. Okay,
Yes.
from the air outside, you know, outside in the air the concentration of oxygen is more, so you are
Yes.
inhaling oxygen. So what is happening, that oxygen is going from its higher concentrated area towards our lungs, in which the concentration of oxygen is
Yes.
less. So this is an example of diffusion in our body. Similarly, the nutrition, the cellular nutrition. What happens is that sometimes the nutrients, they go from inside the cell, okay, and they go by a process of diffusion. That outside cell, there are more nutrients, and your cell need the nutrients. So what will happen? There will be diffusion of the nutrients, right?
Yes.
So this is what we
Yeah.
say diffusion is. So can you now tell me
Mhm.
the definition of the diffusion? What will be diffusion?
Uh, diffusion is where like a lot of particles, for example, like ions or molecules or
Hmm.
like atoms, maybe. Yeah, it goes from high, like high
Hmm.
area of concentration to a low or area of
Hmm.
concentration.
Low concentration. Yeah, to the area of low concentration, you can say. So I am writing the
Yes.
definition. You can also write this. It is the passive movement. Okay, first thing is it is passive movement. What is meant by passive? That no energy is needed to do this. Okay, it is happening naturally. You are not actually
Hmm.
providing energy. Are you providing energy for diffusion? You are not providing
No.
energy. It is
Hmm.
happening naturally. So it is a passive movement
Hmm.
of particles from areas of higher concentration
Hmm.
to the area of low concentration until there is uniform environment. Okay, until there is uniformity. Simply you can write. How much there will be spreadness for how much time? If they ask you what you will write, until there is uniformity. You know there is after some time when you spray
Uniform.
the air fresheners, so there is a
Yes.
fragrance in the whole room after after you can say 2 or 3 minutes. So this is known as diffusion. Now it depends. Now we will see the what happens in the rate of the diffusion. We saw that the gas diffuses because the particle collide with other particle and bounce off in all direction. You know this basically that particles of the gas, they don't have uniform direction. They can move in any direction. I told you a terminology for
Yes.
this that is known as haphazard movement. Okay,
Yeah.
haphazard movement means
That's a hazard
there is
movement.
no haphazard. Haphazard. Okay, haphazardly. The gas particles move haphazardly. What does it mean? That they don't have a specific direction.
Hmm.
The gas particles can move in any direction. Okay, they can move in any direction. So what they are saying, they are telling us that the particles are moving in different directions and they are colliding with each other. They are colliding with each other. And due to this collision, what will happen? They will bounce in different direction. Let's suppose this is one
Each other.
particle and this is another particle. They will collide and
Uh,
then they will bounce in other direction,
yes.
right? This is what they are saying. That due to these collisions, They will bounce in
Mm-hmm.
different directions. Fair? Now they have given you an example. Like, for example, there is an experiment to compare the rate of diffusion. Now you need to check what is the rate of diffusion of different gases. You know, this is quite obvious that all the gases they don't have the same rate because there are different gases, right? Are you getting this? Like, let's suppose you have carbon dioxide, you have methane gas, you have
Yes.
oxygen gas, and you have nitrogen gas. So their diffusion rates will be different, right? Are you agree with my statement
Mm-hmm.
that
Yeah.
the diffusion rates will be different? What
Yes.
does it mean the diffusion rate will be different? Like maybe it will take 10
Like
minutes
it'll
to diffuse. Okay. Maybe it
less.
will,
Yeah. More. Yeah.
yeah. I'm just giving you an example, random values. Methane will
Yeah.
take maybe 10, 20 minutes. Okay. Why their rates are different? What can be the
Maybe
reason?
because of the maybe of the particles.
Yeah, you're right. Just
The,
think about it.
like how like
hmm
maybe how much like how like the amount of particles
The atomic
in
masses. You
the
can say the masses.
yeah atomic masses. Yeah.
It depends on the masses as well as it depends on the surrounding, right? And it depends.
Yes.
Firstly, when we say what you are saying is, you can say the molecular sizes. Okay, it depends on the molecular sizes, the size
Mhm.
of the gases. Okay.
Yes.
Then second thing is it also depends on the temperature, right? It also depends on the
Mm-hmm.
state of the matter. Like, for example, some of the particles in the gas form, and some are also present in the liquid form. You know, the nitrogen is also present in the liquid form, the liquid nitrogen.
Yes.
So it depends on the state of the gas, of the particle, of
Yes.
that molecule,
Mm-hmm.
whether that molecule is in
Yeah.
the gaseous form or whether that molecule is in the liquid form, right? It depends on it.
Yes.
So, what are the most important things on which we can say this depends? The why diffusion rate is different? You can say it depends on the why it is different because there is temperature difference. Firstly, there can be difference in the
Yes.
molecular sizes. Okay, their molecular sizes are different.
Yes.
Okay, their molecular sizes will be different.
Mm-hmm.
Second, there will be I
Uh,
told you the state of matter. What is the state of the molecule, whether that molecule is liquid or gas. Okay, it depends on it. Also, it depends on the temperature. Okay, it depends on the temperature.
mm-hmm.
Like what will happen on a cold day and what will happen on a hot day. Okay,
Hot day. Yeah.
what will be the diffusion rate on the hot day and what will be the diffusion rate on the cold day. So, if you see, the lower the mass, the lower the mass of particle, the faster a gas will diffuse. Because it is easy, right? If you have a small like this one, if you see this, right?
Yeah.
These are small particles, so they can easily diffuse.
Yes.
They can easily go from one place to another. But if you see this one, this is a big particle, right? There is another big particle. So they cannot passively move, right? You need to provide them energy. So there will be less diffusion if the particle size is more. Are you
More.
clear with
Yeah.
this? The lower the
Yes.
mass, the faster the gas will diffuse. Clear?
Yes.
Similarly,
Yeah.
it is the lower its relative molecular mass, the faster the gas will diffuse. Okay. What is relative molecular mass?
Uh,
Relative means you are relating
like
the masses. Like for example,
yes.
you have carbon dioxide and you have oxygen. So you are relating them. Their masses
Yeah.
will be known as then relative masses. Okay. So they are saying the relative
Yeah.
masses, if the relative masses are low, definitely the gas will diffuse at a faster rate, right?
Yes.
Clear?
Mm-hmm. Yeah.
So this is one factor. The second factor is temperature. I told you about the temperature as well. So temperature will also affect the particle movement. How it will affect the particle movement? Can you think about this? Can you tell me what will happen on a cold day and what will happen on a hot day?
Uh, uh,
Like for example,
like,
if you increase the temperature, what will happen? The kinetic energy will
uh,
increase, right?
yes, because it's hot on a hot
Yes.
day.
When you yes, the kinetic energy will increase and definitely the gas will diffuse at a faster rate, right?
Yes.
Gas diffuse fastly, and opposite will happen on a cold day because on a cold day temperature is
Mm-hmm.
less, kinetic energy will be less, right? And diffusion
Mm-hmm.
rate will decrease. Clear? These
Mm-hmm.
are some of the things in
Yes.
the diffusion, which we have discussed in the
Mm-hmm.
diffusion part. Okay, so this is how you can compare it, and they have given you an experiment that there was a cotton wool, they placed it soaked, and there was white smoke from the white smoke will form here for this, and there is a cotton